Hello all, myself Sambasiva Rao, working as Assistant Professor in the Department of Civil Engineering at VNR VJEC. I welcome you all to the lecture series on highway geometric design. The topic of discussion for today will be gradients and grade compensation. So this definition, already we have seen the gradient definition in the cross-sectional elements. The slope along the length of the road is nothing but gradient. So when you are moving along the length of the road like this, so from point A on particular road to point B on the same road. So if you are elevated to some higher elevation, elevated to some higher point, so that will be vertical V and this will be horizontal distance H. So therefore, your gradient is nothing but ratio of vertical to horizontal. So it is always expressed as 1 in n. It means nothing but you have to take the gradient for either 1 meter rise or 1 meter fall. For 1 meter rise or 1 meter fall, so this condition is nothing but rise. Similarly, you can look for fall also. The same point, this is point A and this is point B. So instead of point A at higher elevation, this is the point B at lower elevation for 1 meter fall. Okay. So either ways you have to calculate the horizontal distance. Okay. How much is horizontal distance required to produce for either 1 meter rise or 1 meter fall. 1 meter fall, that is said to be the gradient. So there are different types of gradients present over here. So generally the different types of gradients that are provided in highways are nothing but the first one is ruling gradient, next one is limiting gradient, and next one is exceptional gradient. So followed by last one is minimum gradient. So this is a different category. So all of these three categories, among these three categories, the gradient will be keep on increasing at this in this order. So that is nothing but ruling gradient will be less than that of limiting gradient and exceptional gradient will be higher than that of limiting gradient. So exceptional gradient higher value when compared to that of limiting gradient is higher when compared to that of ruling gradient, and this is minimum gradient that is provided for some other purpose. So you look into the definitions of ruling gradient. So ruling gradient is a maximum gradient adapted to design the vertical profile of a road. So gradient generally is being decided based on the topography of the area. So but it is generally provided to be the ruling gradient, whatever is possible. So that is a maximum gradient that can be allowed to design that road. So that is what the ruling gradient. So it is also called as design gradient. So the main purpose of the ruling gradient is such that it should be such that there should not be any reduction of the speed of the vehicle due to the presence of that grade. Such a gradient is said to be the ruling gradient. Factors such as type of terrain, length of grade, speed and pulling power of the vehicles are going to be affecting the ruling gradient. Next one is limiting gradient. As I have told you that limiting gradient is somewhat higher than that of ruling gradient. Whenever the topography of the given area doesn't allow us to provide ruling gradient, so it requires us to provide somewhat higher gradient when compared to the of ruling gradient. Such a type of gradient is said to be the limiting gradient. So steeper than ruling gradient, in general hilly areas it might be frequently necessary to exceed the ruling gradient and adapt that particular value. So again this is going to depend upon topography and cost in constructing the road. So if you have a area like this, okay, you cannot provide a gradient as it is with the existing conditions. So this might be very high steeper gradient, so you have to reduce it. So because of which you are going to have some other formation level. So this is the existing ground level, but you are going to arrive at this formation level. So instead of having a steeper gradient, you are reducing this by some extent. So this gradient because of which you have to select some gradient which is generally this value is also higher when compared to that of ruling gradient. But even then you are supposed to go ahead with the limiting gradient because of the conditions existing over the location. The last one is exceptional gradient. This gradient is still further steeper when compared to that of limiting gradient. So previously we have been looking this as a limiting gradient. So somewhat even steeper gradient when compared to that of limiting gradient is said to be the exceptional gradient. So whenever even the site conditions does not allow you to go ahead with limiting gradient, then only you are required to provide exceptional gradient. The name itself is nothing but exceptional gradient. So you have to provide that in such cases where you cannot go ahead with the limiting gradient. So that is why it is said to be in the exceptional conditions, the gradient whatever you are providing is said to be the exceptional gradient. So are very steeper gradients given at unavoidable circumstances. They should be limited to short stretches not exceeding 100 meters at a stretch. So even if you are providing a exceptional gradient of 7% as 8%, that should be limited to only 100-meter stretch. Then immediately you should again come back to limiting gradient or ruling gradient. Again you travel for some other distance and again you try to provide the exceptional gradient wherever required. So these are the different gradients, and the last gradient is nothing but minimum gradient, it is a different gradient. So generally, if the terrain is existing is a plain terrain, so and assume that it is approximately horizontal, so where you don't have, already you know the gradient percent cross slope for plain terrain is 0 to 10%. But let us assume that there is a condition where the gradient is approximately 0, where the cross slope is 0, but still you cannot provide the road as it is exactly horizontal. So because of which you may be facing a problem due to draining of rainwater. So because of which you're purposefully providing a small gradient, a small slope over here. So such a kind of gradient is said to be the minimum gradient. So this is generally important only at locations where surface drainage is important. So whenever surface drainage is important, anyhow, if you look into this cross section, you are going to have a camber like this. Okay, camber is going to drain off the rainwater in the perpendicular direction, the transverse direction. But whereas the rainwater collected at the edges should also be moving, so for which you have to provide this minimum gradient. So camber will take off the lateral drainage, but the longitudinal drain along the length of the side drains requires some amount of gradient for smooth flow of water. So that is the main purpose of this minimum gradient. So minimum gradient of generally 1 in 500, a very very less value, to maximum value of 1 in 200. So that is what you can at max you can go for minimum gradient. Again, there is another concept which is said to be the grade compensation. So already you know what is meant by grade, and we also know what is meant by vertical curve. Okay, sorry, vertical curve is nothing but one which is having grade, and you also know what is meant by horizontal curve, which is going to have some amount of deviation angle. So this is my horizontal curve when you look into the plan. So that is nothing but when you are seeing from the top side, you are moving like this and you are coming like this. So in the top view, that is nothing but plan. But whereas if you take the vertical curve, it is nothing but elevation. Rather than plan, you have to look into the elevation just like this. So that is nothing but this is vertical. So you are moving ahead like this upward gradient, and this is nothing but again downward gradient. So this will result in the formation of vertical curve. But whereas this is nothing but you are moving in this direction left and you want to take a right turn in the plan, that is nothing but this is going to form, although both of them looks together. So you have to understand this is horizontal curve which you will be encountering in horizontal curve, and you will be encountering with a deviation angle in the, this you can see in the plan. But whereas this is nothing but vertical curve, and this you can see in elevation. So that is what the difference between horizontal curve and vertical curve. Okay, and there should be some compensation provided some for gradient in some circumstances. Let us look into that. When sharp horizontal curve is introduced, so you have introduced a horizontal curve which is sharp. It means nothing but which is having a higher deviation angle. So that is said to be a sharp horizontal curve, or else you can take that it is having very low radius. Is introduced an road which has already maximum permissible gradient. So there is a combination. So far we have been looking at there is a horizontal curve like this. Okay, and at the same time there is another vertical curve. Okay, and both of them are intersecting. When you are seeing from the top side a plan, there is a right side curve and left side curve like this. At the same time when you are seeing from the top, it is nothing but a summit curve and a valley curve. So it is in combination. You cannot represent over here. So at that conditions, you are providing both. You are providing horizontal curvature and you are providing vertical curvature. So you already provided maximum permissible gradient. So you have reached your gradients, just like what we have discussed, limiting gradient or exceptional gradient, and that gradient has again come along with horizontal curve. In such cases, then gradient should be decreased or compensated for loss of traction effort. So that is what you have to understand. So you are already having gradient which is going to reduce the speed of the vehicle, and it is going to have some impact on the speed of the vehicle. But at the same time you are also providing a horizontal curve, and that is also going to have a combined effect or more aggravated effect on the vehicle. So because of which you have to reduce the effect of horizontal curve or the gradient. So that is what you have to do. In that condition particularly we are going for reduction of the effect of grade. So that is why you are giving some compensation to the grade. So that is why it is called as grade compensation. Okay, you have a horizontal curve which is having a curvature, you have a vertical curve which is having a gradient. So you have to give compensation for either curvature in the horizontal curve, or you have to give compensation for grade in the vertical curve. So generally we go ahead with compensating the gradient. So that that amount of gradient which has been compensated is said to be the grade compensation. So grade compensation is not required for grades flatter than 4%. So your gradient is less than 4%, so then you need not to go for any compensation, even though it is encountered with the horizontal curve. So you are not required to provide the grade compensation, because the loss of the attractive force is negligible when you have gradients less than 4%. The maximum grade compensation is limited to 75 by R percentage. Right, so the formula for compensated gradient is nothing but gradient minus grade compensation. Okay, so whatever the gradient you are having, from that you are going to provide some compensation. So that compensation is said to be the grade compensation, and ultimately whatever the value you are left out with is nothing but compensated gradient. There is a formula for grade compensation. GC is equal to 30 plus R by R. So because this is gradient is provided along with the curve, horizontal curve. So that is why you are going to have radius of curvature. Or the second one is 75 by R. That is already been mentioned over here, 75 by R, whichever is minimum. Of course, in both of the conditions, so this will be minimum value. So that is why it has been mentioned that the maximum grade compensation is limited to 75 by R percentage. Okay, whichever is minimum. Whichever is minimum. And after providing compensation, at any cost, compensated gradient should not be less than 4%. So because you need not to provide grade compensation for grades which are less than 4%. So you are having compensated gradients less than 4% means you have to keep minimum 4%. Okay, so you have to reduce the grade compensation even if it is coming more in both of the cases. Okay, you have to reduce that such that the compensated gradient will be more than that of 4%. So these are the different types of gradients. Generally, we will adopt in different types of terrains. One is nothing but plain and rolling terrain. Generally, we'll go ahead with 3.3. So this is 3.3%, and this is 5%, 6%. Rolling gradient in plain or rolling terrain, mountainous terrain, steep terrain. So 3, 5, 6, and 5 will be shifted over here, 6 will be shifted over here, and 7 will be coming extra over here. So these are the general standard values which will be adopting. So you can deviate a little bit from this. So and this is again 6 will be shifting over here and 7 will be shifting over here, and you will be introduced with 8 exceptional gradient in steep terrain is 8%. So generally these are the different values that are adapted in highways. So there is a small problem over here. So determine the grade compensation and compensated gradient. So you have to look for grade compensation and compensated gradient for a steep road with a ruling gradient of 5%. So if you look into this table, 5% is been over here. So it can be either a plain terrain, we don't know about the type of terrain, but it might be a plain terrain which is provided with some limiting gradient. So that might be the condition. It might be a plain terrain where they might have provided limiting gradient, or it might be a mountainous terrain where the ruling gradient. So they provided a ruling gradient, but the terrain is nothing but mountainous terrain. So you are going to have 5%, and either ways you are also having, but that has become a limiting gradient for plain terrain. The same value has become limiting gradient for plain terrain. So it might be any of the case, but we are not bothered about the case what is been, but we are just required to calculate what is the compensated gradient. So ruling gradient is given, so that is nothing but ruling gradient is nothing but simply gradient. So it has been given as small n percentage. So already we have looked at the representation of grade which is nothing but 1 in n. Vertical to horizontal or small n percentage. So 1 in n, if you multiply with 100, you will be coming across with some percentage value which is nothing but small n percentage. So that has been given as 5% in this case. So now you are asked to calculate first compensated gradient. We'll just calculate what is grade compensation over here. We already have the formula which is nothing but 30 plus R by R or 75 by R. 30 plus R by R is nothing but 30 plus R is nothing but 150 divided by 150. So this is what the value, and you will be having somewhere around 1.2% as the grade compensation by the first formula. And you also have the grade compensation is nothing but 75 by R. So 75 by 150, which is nothing but 0.5%. So this is 1.2 and this is 0.5. As for our formula, this is nothing but whichever is minimum. So you have to provide whichever is minimum. So whichever is minimum is nothing but 0.5%. So you have to subtract 0.5 from the original gradient. So you know the formula for compensated gradient, CG is equal to ruling gradient or gradient minus grade compensation. So your gradient is given as, how much is that? 5%. So we have calculated. So the gradient is given as 5% and the grade compensation is whichever is minimum is nothing but the second case, which is nothing but 5.5%. So your compensated gradient is nothing but 4.5%. So this is nothing but compensated gradient. Compensated gradient. Grade compensation is nothing but 0.5, whichever is minimum. So the minimum condition is nothing but 0.5. So this is the first condition. And then the second condition is determine the grade compensation, the compensated gradient for the steep road with a ruling gradient of 5%, but the horizontal curve of radius 75 meters. The same question more or less, but the radius has been changed to a different value. Okay, so therefore we are again required to calculate what is meant by compensated gradient. So here grade compensation is nothing but 30 plus r by r. 30 plus r is nothing but 75 divided by 75, which is nothing but 1.4%. So the grade compensation by the first formula is 30 plus r by r is 1.4%, and the other formula which we are having is maximum, it should be 75 by r. So 75 by r is nothing but again 75, which is nothing but 1%. Is nothing but 1%. Again, whichever is minimum, so this is case 1 and this is case 2. Whichever is minimum, so we have to provide the minimum value. So I'm going to reduce the compensation, that is nothing but grade compensation, I'm going to provide only 1. So therefore, compensated gradient CG is equal to, gradient is nothing but 5% minus grade compensation is nothing but 1%. So that is nothing but 4%. So but we have to remember the check, that is nothing but at any cost the compensated gradient shouldn't be less than 4%. Here the compensated gradient is nothing but 4.5%. Anyhow it is greater than 4. It is not less than 4. And here it is exactly 4. So you have to keep as it is. But whereas if I just change this extend this question somewhat more, so instead of 75 meters, if I provide 50 meters as a radius, now we look into the updated calculations. So again, grade compensation is nothing but 30 plus r by r, which is nothing but 30 plus 50 by r50, which is nothing but somewhere around 1.6%. And other formula is 75 by r, whichever is nothing but 75 by 50, which is nothing but 1.5%. So here whichever is minimum, again as the previous statement suggests that you have to restrict the grade compensation to 75 by r percentage. So we are going to restrict it to 1.5%. But you look into that compensated gradient, which is nothing but CG, is nothing but gradient, which is nothing but 5% minus 1.5. If I take whichever is minimum value, so I'm going to end up with 3.5%. So but whereas the code recommends that at any cost the compensated gradient should not be less than 4%. So here we shouldn't provide anything less than 4%. Now in this condition you have to take CG, compensated gradient, is equal to ruling gradient, let it be as it is, minus you have to find out grade compensation, let it be x. How much ever you can provide grade compensation, that you have to check back. So here this is exceeding, this is coming less than 4%. So you have to fix this as 4% first, and 5 minus x. So x will be 1%. So x will be 1%. So it means nothing but, even though the farmer recommends you to go ahead with 1.5% grade compensation, but you are allowed to go only with 1% grade compensation. So 0.5 will not be reduced from this. So such that because you should have a minimum value of 4% ruling gradient after compensation. So that is nothing but the leftover gradient, compensated gradient, should be equivalent to at least 4%. So I sincerely acknowledge the use of publicly available resources that supported and enhanced the visual clarity of this presentation. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.